Third one. Now this is related to thermodynamics and its properties. Give me a second again. Sorry for that. The setup shown in the figure was used to calculate the heat chain associated with the dissolution of the salt MX. Okay. So they have used 100 cubic centimeter of water. So I will write down here 100 cubic centimeter of water is used. Okay. The initial temperature of the distilled water. So initial is 25 degrees Celsius. I would write like this. This is initial, ini, and final. So they have added 0.1 moles of X. Okay, don't forget this is 0.1 mole of X, mx in fact, the salt. And they have started the solution, and finally they would obtain a final temperature of 17 degrees Celsius. Okay, so basically what it says is there is a temperature drop. Density and heat capacity, you should take that as in water, and you need to neglect that when you dissolve MX, this density and heat capacity is changed. Okay. So calculate the amount of heat that should be supplied to bring the system solution back to 25. So basically the first point that you need to understand here is when you dissolve this MX, the temperature is dropped. Okay, which means it has absorbed the heat. Okay, which means the dissolution of MX is now an endothermic process because temperature is dropping down. It absorbs heat from the surrounding. So if you want to bring back the system again to the same temperature, you need to give the same amount of energy that it absorbs. So basically you need to calculate the energy that is necessary here. But you don't have given any enthalpy values. Here you don't have the enthalpy of the solution. So what you can do is typically use the typical equation. H is equal to mc d theta. This equation comes from your O level. And believe me, there are few students that even don't know to use this equation. Therefore, they are telling this question is very difficult because they don't remember. That is the first point. Sorry again. So to calculate the mass, what you can do here is use the density as well as the volume solution. Okay, volume of the solution. So this would be 1 grams per cubic centimeter. You can turn this into kilogram by multiplying 10 to the power minus 3. And then 100 cubic centimeter is here. And C is given 4.2 joules per gram per degree Celsius. MC is there. M is calculated here. C is there. D theta. So what is the difference here? 25 minus 17 is 8, right? So 8 degrees Celsius. So you multiply this. Okay. Then you will get an answer for this one. So it is 3.36 kilojoule. In fact, 3.36 kilojoule. Okay. Is the dissolution of MX in water is an endothermic. So this is an endothermic process. Why this is endothermic? The temperature is dropping down, which means it absorbs water into the system. Therefore, this is an endothermic process. That is what you have to explain here. Calculate the enthalpy change associated with this reaction. So you know this is an endothermic, so the enthalpy change should be a positive value. So how do you calculate the enthalpy? So you need to calculate this one in kilojoule per mole. So you know that the energy that is required for this dissolution is 3.36 kilojoule. Okay, so now you need to find this for 1 mole. That is what kilojoule per mole means. So you just need to divide this by the number of moles that you have used. Now here we have used 0.1 moles. So you divide this by 0.1 moles. So basically it is 33.6 kilojoules per mole. That is what it requires. Okay. If this experiment was conducted using 200 cubic centimeter of water, would you expect the temperature change to be larger than above? Explain your answer. Okay. Now think, here we have used 100 cubic centimeter. Okay, let's say this is filling up to here. For an example, 100 cubic centimeter. When you use 200 cubic centimeter, okay, 200 cubic centimeter. Let's say this is filling up to here, this whole area. Okay, now we are using the same amount, but you have more space now to give away the energy, which means if you have used 200 cubic centimeter, there will be more water molecules that can give away energy to this mx. Okay, which means this temperature drop is now should be lower than the initial case, because this temperature difference is 8 degrees Celsius, because you have only 100 cubic centimeter that can accommodate this amount of energy difference. But when you have more water, which means you are increasing the volume now from 100 to 200, there will be more space that can be given, okay, to the amount of water molecules that you have. Why? Because when the dissolution happens, the enthalpy per mole, this is not going to change. The amount of heat energy is same, because you are using same amount of moles, 0.1 moles, but you have more water molecules. Okay, you have more water molecules in the system to release this heat. Okay, so therefore this temperature drop will be small now. Small means here it is 8 degrees Celsius. Here most probably it will be like 4 degrees Celsius, the difference. Okay, that is what they are telling. So show the variation of the temperature of the system solution by drawing the temperature time curve. Note, eventually the system reaches the room temperature. So basically what they are telling is draw the curve. So initially it is 25 degrees Celsius. Okay, then if I take this as 17, and if this is 0 here, what would happen? Normally it would decrease like this when the dissolution is completed, and then over time it will come to this 25 degrees Celsius. That is what they are. Then it goes like this. Now it is constant. Okay, so think about this thing a little bit. Right, next question. In this experiment, why they're asking why they have used a plastic cup instead of a metal cup. So this is very straightforward. When you use metal cup, what is going to happen? Metals are good conductors, so it will also absorb certain amount of energy or release certain amount of energy. Okay, so that is a problem. So metals are good conductors, in fact thermal conductors. Okay, so when the temperature is decreased, what would happen? Metal provides and conducts heat from the surrounding. So that is what normally going to happen. So we have to use a cup which has a conductivity, which has the conductivity very minimum here. That is why they have used a plastic cup. Okay, why they have used a plastic cup? Because they have the minimum conductivity and they do not absorb heat from the surrounding. For an example, if you use a metal one, when you dissolve this, you know now the temperature is decreasing. So when the temperature of the system decreasing, the temperature of this metal cup also will decrease. Then what it does is absorb heat energy from the surrounding. Okay, to avoid that, you need to use like a plastic cup instead of a metal cup. That's the reason, right? The Gibbs energy change delta G for the dissolution is given at 25 and 1 atm is minus 26, and you need to calculate the entropy change. Okay, so remember here one important thing that you need to understand, and students make mistake. The equation delta G equals delta H minus T delta S. This equation can be used here. There is no problem. But you cannot write this equation as this form. Delta G theta is equal to delta H theta times delta S theta. Because if you write this one in this form, surely you are going to get no marks. Because check the question really carefully. They have given delta G, not delta G theta. They have asked delta S, not delta S theta. Okay, because that is they are not considering about the standard condition. Okay, so when you are answering this question, you need to use the equation delta G is equal to delta H minus delta T delta S. So delta G is given, I guess, yeah, minus 26 kilojoule per mole. So delta H, we have already calculated that, 33.6 kilojoule per mole from the previous questions. And minus temperature is 25 means 298 Kelvin. So then you can find delta S. That's it. Okay. Last question. Would you expect the solubility of MX to increase or decrease with increasing temperature? So here, you know, this is MX solid. Okay. So it would form M plus and X minus. Okay. So if this is reversible, you know, this forward process is endothermic, a cooling process. Backward is exothermic. So when you heat, what does it mean? You are heating more and more. Okay, so this is a heating process. So what the system does, the opposite, which means cooling process. So the dissolution will increase here. That's the idea. Okay, so the solubility of MX will increase with increasing temperature. What is the reason? The dissolution is endothermic. Or either you can say the delta G will become more negative. Okay, based on this equation.